Hi, hi, welcome back to AP Physics, C, Electricity and Magnetism, Unit 3, where our focus is going to be on circuits. So in this video, we're going to look at resistance and Ohm's law. Okay, two very important concepts when it comes to this unit. So before in the last video, we talked about this resistivity, right? So this is basically telling us how much the material is going to resist kind of the current flow. It's given the symbol rho. So, and that leads us to a different term, which we mentioned before, called resistance. So the relationship for resistivity and resistance is the resistance. So this is in a wire, right? So it's going to be that resistivity times the length of the wire divided by the cross-sectional area, right? So this is the length of wire. And this is, again, our cross-sectional area. Okay. Now, resistance is defined as the opposition to current, right? So this is what, objects will use to get that power. And we can calculate it in various ways. And you can see over here, this is something we call the Ohm's law triangle. So resistance is defined as voltage over current, okay? Now, resistance is going to be measured in ohms, which is named after George Ohm, who did the research here. Play a little play on words with the join the resistance. You can see the ohm. So the basic mathematical relationship between resistance, current, and voltage is defined as Ohm's law, and that's that R equals VI. And if you actually start searching on Google, searching for Ohm's law, one of the options will pop up will be Ohm's law triangle, and that's what I circled over here. So Ohm's law you see generally written as V equals IR, but you can solve it for the other two factors or variables by just simply using our triangle. Now, sometimes the material will be ohmic, sometimes it'll be non-ohmic. So if you do a lab or an activity in which you find that if I plot V versus I, voltage versus current, and it is a straight line, then the material is what we call ohmic. So it behaves like Ohm's law. When you start getting into the curve sections, right, then it's non-ohmic, which means it doesn't behave or doesn't follow Ohm's law. And this, again, may pop up on a free response question. It may pop up, something with these graphs here that you can see. Some materials are ohmic to a point, and then once you get past a certain barrier, then they become non-ohmic. Some are just straight non-ohmic. And again, you would have to collect the data to see what happens, okay? We're going to get a lot of work with the V equals IR equation. So our example question or example problem is we're going to use this R equals rho L over area. And so here that is. So now again, we go back to our 14 gauge. So 14 gauge wire, the way to talk about wiring, that tells you the diameter of the wire in a certain way. So we're going to calculate the resistance per unit length of a 14 gauge wire that is 2 millimeters in diameter. And the resistivity of copper is 1.7 times 10 to the negative 8th ohm meters. This is not, I'm not saying this isn't a traditional type question, but we're not looking for the resistance. We're looking for the resistance per unit length. Okay, so what I need to do with the equation is simply divide both sides by L to get resistance per unit length. Okay, a lot of times you will solve it by R by just saying, hey, you have a 5 meter long wire, right? What's the resistance? Okay, and so then you would not solve for R over L, you would just keep it solve for R. It may look for the resistivity by giving you R and A and the length, but this one is simple. All we're going to do is rho over A. So it's going to be 1.7 times 10 to the negative 8th divided by A. So pi times 0.001 squared. Again, they give us a diameter, so we need to cut that in half, right? So lowercase r. I know there's a lot of r's running around here. But make sure you do convert this because these two units need to be in the same unit. And so we're going to do 1.7 times 10 to the negative 8th divided by pi times 0.001 squared, and gives us a resistance per unit length of 5.41 times 10 to the negative 3 ohms per meter. Okay, so this is, remember, this is going to be in ohms per meter. This actually is going to end up in meters squared. So those cancel, and there's our ohms per meter, our resistance per unit length. Okay, so in the next video, we're going to start to look at our circuits and how do things behave.